Somewhere in the constellation Virgo, about 10.4 billion light-years away, there is something that should not exist. It has a mass 66 billion times greater than our Sun. Not 66 million. Billion. Every second, it consumes enough matter to make several Earths. And the light it produces, it outshines every single star in our galaxy combined. By every measurement we have, nothing should be able to get this big. And yet, here it is. This is the most extreme object ever discovered in the observable universe. And when you understand what it actually is, you will never look at the night sky the same way again. The story starts in 1957 at a French observatory called the Haute-Provence Observatory. Astronomers cataloguing the sky logged something strange, an object in Virgo that appeared faint, almost forgettable, but gave off a bizarre spectrum of light that didn't match any star they'd ever recorded. They filed it, moved on. The universe is large after all, and strange-looking stars were not uncommon. But in 1970, a team revisited that object and measured its redshift. Redshift tells astronomers how fast something is moving away from us, and by extension, how far away it is. What they found was staggering. This wasn't a faint star in our own galaxy. It was billions of light-years away. At that distance, to appear even as bright as it did from Earth, it had to be producing an almost incomprehensible amount of energy. They were looking at a quasar, one of the brightest, most energetic objects in the known universe. And it had been sitting in a French sky catalogue for over a decade with barely anyone noticing. But the real discovery came decades later, in 2004, when astronomers used spectroscopic data to measure what was actually powering that quasar. What they found at its center stopped them cold. The object driving TON 618 is an ultramassive black hole. Not supermassive, which is the term we usually reach for. Ultramassive, a category scientists use when supermassive no longer feels like enough. At that point, they had found the largest black hole ever confirmed. To understand what TON 618 is, you first have to understand what a quasar is. And to understand that, we need to go back to black holes. Most large galaxies have a supermassive black hole at their center. Our own galaxy, the Milky Way, has one called Sagittarius A star. It has a mass of about 4 million suns. That sounds enormous. Compared to TON 618, it is almost nothing. When a black hole is actively feeding, pulling in enormous amounts of gas and dust, that material doesn't fall straight in. It forms a disk around the black hole, spinning faster and faster, heating up to millions of degrees. The friction and magnetic forces in that disk cause it to radiate intensely. A quasar is what you get when this process is happening at extreme scale. The energy released from the disk around a feeding black hole can outshine the entire galaxy surrounding it. TON 618 is producing about 140 trillion times the luminosity of our Sun. If you were to replace our Sun with TON 618 at the same distance, it would incinerate everything in this solar system in moments. Every planet, gone. But here is where it gets genuinely strange. The black hole itself is not visible. You cannot see it. What you are seeing when you look at TON 618 is the superheated material around it. The black hole is the engine. The quasar is the exhaust. And the size of that engine, scientists measure it in what they call the Schwarzschild radius, the point beyond which nothing escapes. For TON 618, that radius stretches about 1,300 astronomical units across. 1 astronomical unit is the distance from the Earth to the Sun. The event horizon of TON 618 spans 1,300 of those distances. Our entire solar system fits inside it, with room to spare. The human brain was not built for numbers like these. We do not have an instinct for distances measured in billions of light years, or masses measured in billions of suns. So let's try to feel it. Our sun is roughly 1.4 million kilometers wide. It is so large that about 1.3 million Earths could fit inside it. Spend a moment with that. Now take that sun and multiply its mass 66 billion times. That is the mass of the black hole inside TON 618. If you stood at the outer edge of our solar system, the sun would appear as a bright star in the sky. Nothing more. Now imagine replacing that star with the event horizon of TON 618. It would fill roughly 40% of your sky. Not a star. A wall of darkness surrounded by a blazing ring of light millions of degrees hot. The relativistic jets that shoot out from TON 618, streams of plasma moving close to the speed of light, extend for tens of thousands of light years in both directions. The Milky Way galaxy is about 100,000 light years wide. These jets cover a significant fraction of that distance on their own. And the question that genuinely unsettled astronomers when TON 618 was fully characterized: how did it get so big so fast? The universe at the time TON 618 was actively feeding was less than 4 billion years old. Getting to 66 billion solar masses in that time frame breaks every model we had for how black holes grow. We still do not fully have an answer. Black holes grow by consuming matter, gas, dust, stars that wander too close. At the outer edge of what physics predicted, a supermassive black hole could reach a few billion solar masses given enough time and enough food. The leading explanation involves the earliest black holes in the universe seeding from collapsed massive stars, then experiencing long periods of near maximum feeding, compounded by galaxy mergers that delivered fresh material repeatedly over hundreds of millions of years. But even those models strain. The feeding rates required are at the theoretical ceiling of what physics allows. And some researchers have suggested that early universe black holes might have formed through pathways we haven't confirmed yet, perhaps directly from the collapse of enormous gas clouds without a stellar phase at all. TON 618 sits at the far edge of what we can explain. It is not just the largest black hole we know of. It is the object that asks the hardest questions about how the universe assembles things in the first place. And here is the thing worth remembering. We are seeing TON 618 as it was 10.4 billion years ago. The light reaching us now left that quasar when the universe was young. What it looks like today, whether it is still active, whether it has grown further, we have no idea. That information hasn't reached us yet. The universe, it turns out, does not ask for your permission before building something impossible. TON 618 existed before our solar system formed. It fed for hundreds of millions of years. And by the time the first complex life appeared on this planet, the light from that event was already crossing the void toward us, carrying a message that took 10.4 billion years to arrive. This is what the universe looks like at the extreme end, and we have barely started looking.